All right. So uh, to, today we get to learn a cool trick that you already know how to do, kind of. So here's the issue. Maybe from two separate approaches. One issue is if I think about a as a function, right? Going from someplace to someplace else. So if A is an n by m matrix, what's this space over here? How big are the vectors that an n by m matrix can be multiplied by?
N M. But that's my bad.
Yeah, they've got to be m because that's kind of the that trailing number, right? So this
Okay.
is rm gets
See.
turned into rn.
Oh, okay. I got confused because I don't know when. It must have been near the very beginning of the class, but we were talking about a matrix, and it was written down, like 3 by 1, but it was like, I don't know, it was 3 tall, and that's kind of what confused me right there. Anyway.
Mm, yeah, so n is the tallness, which is the number of rows. That's true.
Okay, got it. Thank you.
Okay, so in this case, that it's a function, right? Do you guys ever have occasion to like I don't know compose functions? Is that like a thing that you've ever seen in math class before? You know,
A
where you
100%.
really? When do you see that?
I think we first saw it in like pre-calculus.
Yeah,
Fog.
yeah, exactly. So I'm hoping that you've seen function composition before, right? So, for instance, if I had two functions like, say, f of x is x squared and g of x is e to the x, that would mean that if I started with a number over here and did f to it and then did g to that, right, what would I get? In other words, what is g composed with f?
EX squared.
Good. This is e to the x squared. One way you can think about that is you can think about start with an x here, apply f to it, you get x squared, and then do this to it, which means put it in the exponent of an e, so you get e to the x squared, and so x goes to e to the x squared. You guys all with me on that function composition model? Since I've had you guys for Calc 3 and maybe not for other stuff, have I drawn this picture before?
I don't think so.
Okay. Does it make sense though?
Yes.
Okay, cool. So, same deal here. A is a function. It makes sense that I might wonder what if I did another matrix B to this? I'm not really sure what kind of size I'm going to put in here. I'll just put, well, wait. I bet there is something about the size in there. What do I know for sure has to happen here?
Should have M.
Have a which?
It should have M, like
Eh,
M cross something.
yeah, I think we're going to. So, I okay, so let's see. If I analyze this symbol, right? I have kind of function name up here. And then these two, I have my n by m. right? Which one is this? Is that the domain of A or the range of A?
Range?
Which one's this?
Domain.
Uh-huh. So this is the domain of A. And then this is the, well, okay, so range is a shitty word here. I'm going to use the word codomain, and we'll talk about why later. Okay? You can think about it as a range for right now. There's a subtle distinction there, but for right now, I don't want to completely overwhelm you. So when I've got my matrix B here, what do I know about B? Do I know about B's domain or range when I'm looking at this space here?
Can you repeat the question?
So is this space right here at the beginning of the B arrow, is that B's domain or B's range?
Domain.
Good. So domain goes in that second spot, right? So I don't know what goes in the first spot. I'm just going to put K in here. But I do know that that second spot has to have an N in it. Otherwise, I can't do this. Does that make sense? Then this spot's going to be R. Oops, not K down there. This is going to be RK. Guys with me on that? Okay, and then if I think about this function that goes from here to there, so from here to there, first, what would I name it? And second, how big a matrix should it be?
I'm going to guess a 3x3 matrix.
It's gonna be a K by M matrix.
K by
M.
M?
Yeah,
Why?
because so like over here, right? We named it as N by M,
Mm-hmm.
and then this one was K by N. So if we go from the first one to the last one, right? It should be K by M then.
Exactly. Very nice. Yeah, the first letter is the range size, and the second letter is the domain size, right? So this thing maps, right, from here. It's M domain and K range. You guys see that? Okay, now, harder question. What is its name? And don't say C, because that's a smart ass maneuver. I could see you thinking it, Karen.
Can we do a AB?
Okay, yeah, so this is the tendency is that you'd want to call it AB, right? But remember that when we're composing functions, right, you write the one that you're doing to the variable first, closest. So which of these two comes first in this journey from left to right here?
A?
Yeah, A comes first. So A comes first, and then B. You guys all buy into this idea?
No.
For the same reason here, right? That the first thing I'm doing to X is F, and then the second thing that I'm doing to the result of that is G.
Okay.
So you might think about this as I'm doing B to A to X. Does that sort of make sense? Okay, cool. All right. Now, with this standpoint, would it make sense that AB is not the same thing as BA?
Yes.
Good. Don't screw this up. The order of matrix multiplication matters. In general, sometimes one of these is defined and the other one isn't even defined, much less they're the same matrix. You guys see that? Okay, so this is the kind of function level approach to matrix multiplication. You just think about them as a function and they go from one vector space to the next. You guys good with that? And if I want to multiply matrices, that's the same thing as composing functions. Okay, I'm assuming we would like to see an example for how to actually do this. Is that correct?
I would love that.
Okay, good. So, in order to actually go about doing this, I need a definition for how to actually multiply A and B. So, I'm going to write down a definition and then we could check that this actually satisfies the properties that I just claimed it did. So I'm going to take a matrix A and I'm going to multiply it by a matrix B. I'm going to think about the matrix B as a set of columns that I'm going to call B1 through Bn. You guys good with this? Questions, concerns, things? Okay, so in order to actually do this, what I'm going to do is I'm going to take my matrix A and I'm going to multiply it by each of the column vectors, and that is going to make me a new matrix. So I'm going to have A times the first column, and then A times the second column, and I'm going to do that until I'm out of columns. Does this make any sense? Okay, now I'm going to assume that you still want an example. Is that true?
Mm-hmm.
Okay. So let's multiply the matrix 1, 0, 1, 1 by the matrix 1, 3, 2, 4. Okay, so what are my columns? In here. How about what's the first column of this matrix?
1, 2.
Good. So my first column of this my result matrix is going to be 1, 0, 1, 1 multiplied by 1, 2. You guys see that? And then my second column is going to be what?
1, 1, 0, 1 multiplied by 3, 4.
Cool. I think that when you said this matrix, you said it in a different order than we usually read them. Just no problem, but FYI, usually people read matrices by rows.
Got it.
Not a huge deal. Just it'll be confusing if I train you the other way. Okay, so now we want to do those multiplications. How do I go about doing those multiplications?
You do it.
Yeah, just do it. You can do the row picture or the column picture. I care not at all. So if I go do that, I take 1, 2 time dotted with 1, 0, and I get 1. And then I take 1, 2 dot with 1, 1, and I get 3. And then for your next entry, what's my entry up here?
3,
That one is 3, and this one is
7.
perfect. Do I expect you to write this step out each and every time? No. Hell no. Right? Just pick this row up, twist it sideways, drop it on. That gives you this number. Pick that row or column up. Pick the column up, twist it sideways, drop it on. Pick the column up, twist it sideways, drop it on. Just remember that they go in columns in order. Or use a calculator. I don't give a shit. You guys good with this? Okay, now one thing I might notice looking at this thing, the that top row stayed the same, and the bottom row got the top row added to the bottom row. You guys see that? This bottom row is just the top row plus the bottom row. That's kind of weird. This matrix is a special example of something that works a little bit like an elimination matrix. So we're going to lean on that a little bit later here if we get the time. There are matrices like that covered in section 2.3. Okay, so next. Do you guys want another example? Yeah.
I think I'm all right. I don't know how everyone else is feeling.
Okay, let me ask one more question anyway. So suppose I had the same 1, 0, 1, 1, and I wanted to multiply that by 3, 2, 1, 1, 2, 3. Explain to me something about this. Like, what is this?
So we have a 2 by 2
Okay.
and a 3 by 2.
Okay.
Those two middle numbers aren't the same, so we can't do that matrix.
Good. Perfect. This is not well defined. So, no. Equals no. Right? This thing doesn't make any sense. Why doesn't it make any sense? Well, because this first thing, right, is a map from 2 space to 3 space, right? And then this second thing is a space from, or is a map from 2 space to 2 space. So what we're trying to do with this picture, right, is we're trying to take R3, or sorry, we're trying to take R2, turn it into R3, And then we're trying to turn R2 into R2. And these functions just can't follow each other in that order because these spaces are not the same. Yes, exactly. R2D2 all the way. Does that thought process make sense? Now, thinking about it in terms of functions is a little bit harsh. Usually I just look here and say, yeah, no. Good with this? If you punch this into one of the calculators, they'll throw a dimension mismatch error, which is always confusing for students. Traditionally, this means that you've thought about these in the wrong order, because if you switch these two matrices, you can multiply them. Does that make sense? So if I swapped them, right? So if I took my matrix 3, I told Jordan I say this the other way, and then I read it the wrong way. So this is 3 1 2 2 1 3. I'll try to do better on consistently reading. Times 1 0 1 1. Can this multiplication be executed? Okay, what's the result going to be?
3 by 2?
Good. It's again going to be a 3 by 2 matrix. Because this first function takes things from R2 to R2, and then this second one takes things from R2 to R3. So ultimately, it takes things in R2 and turns them into things in R3. 2 to 3. Questions on that? Okay. Last thing last. The matrix that's ones down the diagonal and zeros elsewhere is denoted with I n by n, which is said identity matrix in R n. Why is this called the identity matrix? So the 2 by 2 identity matrix, right, is this guy. Why is this called identity? You guys know another math meaning for the word identity?
It's equal to itself.
Well, yeah, everything's equal to itself.
Well, when you do an identity matrix to a vector, it is the individual components of that vector.
Yeah, that's the key. It's the self map, right? It takes a vector and leaves it alone. You guys see that? The reason it's called identity is that this whole thought is kind of thinking about the multiplicative identity, which is also sometimes called 1. Right? It's the number you multiply other numbers by and it leaves them alone. Same thing here with matrices. So if I take I 2 by 2 and multiply by a vector x, I get that same vector x. That is true of all the n by n i's. I do have a tendency to drop this. Often left off. So if the dimension that we're in is pretty obvious, I'm going to leave that off. Does that make sense? Okay. Do also add to your brain that this friggin' thing has to be a square. If it's not a square, it's not the identity matrix. Even if it looks like one, it's not. So that would be things like 1, 0, 0. Things like 1, 0, 0, 1, 0, 0. Also not the identity matrix. You guys see that? So if it has padding of zeros, it doesn't count. You guys cool with that? Why would that make sense? Like, why aren't those called the identity matrix? Should be pretty clear that something changes about the vector. What is it?
It's that last row, or it's one of those rows or columns that you're just turning to 0.
Yeah, it's changing the dimension of the input, right? You guys see that? So the reason I want it to be square is that this should take an n, in this case 2, right? But in general, whatever vector, and it should leave it alone. That means it can't change its size. That's not leaving it alone. You guys see that? Those matrices are interesting. They're just not the identity. These ones, the ones that are more columns than they are tall, are projections. They smash things. And these ones are called embeddings. They stick two-dimensional vectors into three-dimensional space. They're both interesting things. We're going to spend some time talking about each concept, but they're not identity matrices. We good with that?
So what if with the identity matrix, instead of going from the top left to the bottom right, we went from the bottom left to the top right?
Sick. Okay. Hang on. Let me do this. Yeah, so gosh, I really should add this in both places. So let's oops, not that one. This one. No, what the hell? This can be a long video. Okay, so Jordan wants to know about this matrix. Are you with me? Okay, let's think about what that does to a vector xy. What do you get? Do some pickups and drop-ons.
YX.
Yeah, you get the vector yx.
The exchange matrix.
Yeah, this one exchanged the rows, right? You guys see that? So these kind of matrices where they've got kind of ones and zeros, and they've got that same property that the identity matrix has, that each row has at most 1 1 and each column has at most 1 1. These are permutation matrices. It swaps the order of the rows around. And it should be noted that it swaps the row orders when it's multiplied from the left. Does it make sense that I need to differentiate between left multiplication and right multiplication?
No.
Okay. Remember a bit ago when we said that BA and AB aren't the same thing?
Yeah. Okay.
So to add to that, uh, this one is left multiplication of A, and this one is right multiplication of A. Right, so I'm multiplying A on the left of B, and I'm multiplying A on the right of B. Maybe I should actually let me phrase that fully so I don't screw you guys up. This is B was multiplied by A on left. And this was B was right multiplied by A.
You got a lot louder.
What's that?
You just got a lot louder.
And there's a lot of background noise now.
Oh, damn it.
That happens. I've heard it a couple times during class. It's just like your mic all of a sudden it's like, oh, things are too quiet. Time to bring up the gain.
Is it still jacked?
It's better now.
How about now?
Yeah, that sounds good.
Okay. Thank you, guys. I don't know why I've been having sound driver problems. So if it gets too weird, do exactly what you guys just did. Let me know. Because I don't want to make a recording with crappy sound. All right. Did this process make sense?
Yeah.
So in keeping, actually, yeah, let me stop this.